Hello there, and welcome to Deep Earth Stories. Get comfortable, turn the lights down if you can, because what we are about to explore together has been waiting a very, very long time for someone to listen. But before that, please subscribe to my channel and tell me in comments where are you listening from and what time is there right now. Tonight, we're going to go somewhere very far away. Not far in distance, not across an ocean you could find on a map. We're going somewhere far in time, deeper than memory, deeper than history, deeper than anything written in any book. We're going back to the oceans of the ancient Earth, the oceans that no human ever saw, the oceans that came before the fish, before the coral, before even the first creature that dared to crawl onto dry land. Maybe you're lying in bed right now. Maybe the room is dark and quiet. Maybe you have your headphones on and the world outside feels very far away. That is exactly where I want you to be, right here, still, soft, breathing slowly. You do not need to remember everything I tell you tonight. You do not need to take notes or stay fully awake. This story will carry you gently, like water carries a leaf. You just need to let go and float. So if your eyes are already heavy, that is okay. If your breathing is already slowing down, that is perfect. Let it slow even more. Let your shoulders drop. Let your hands go loose. Tonight we're going to drift through some of the oldest, most mysterious, most beautiful seas that ever existed on this planet. Oceans so old that the continents were in completely different places. Oceans so vast that they covered most of the world. And oceans so quiet and so strange that we can barely imagine them, even with all of our science and all of our wondering. And I promise you, this journey will be gentle. There is nothing here to fear. There is only deep time, slow water, and the soft hum of a world becoming itself. Let us begin. Close your eyes for a moment, if they're not already closed. Imagine a world with no people. No buildings, no roads, no voices, not even a bird calling in the distance. No bird has been born yet. No tree has grown its first leaf. Even the land itself looks strange, grey and bare and ancient, like a stone left in the sun for 1 billion years. Now look at the water. It is everywhere. Not the clear blue water you might picture when someone says ocean. This water is different. It is older. In some places it might look slightly greenish or pale. It is lit by a sun that is a little dimmer than the sun we know today. The sky above it is not the deep rich blue of a summer afternoon. It is a different shade, a little hazier, thicker with gases that have no name yet in any human language. But the water moves, it has waves, it has tides, it has depth, it is real, and it is alive in its own slow, ancient way. This is the Earth before us, the Earth before almost everything we would recognise, and yet this water is not empty, not completely, because even in these early, strange oceans, something is happening, something quiet and small and almost invisible, the very first stirrings of life itself. We will get to that. But first, let us understand how these ancient oceans came to be, because the story of Earth's forgotten seas begins not in the water, but in the sky, and even before that, just in the cold, dark emptiness of space. About 4.5 billion years ago, our solar system was forming. Imagine a vast, spinning cloud of gas and dust, slowly pulling together, clumping, spinning faster and faster. At the centre, the sun was being born, gathering mass, growing hotter, and around it, like tiny whirlpools in a slow river, small pieces of rock and ice and metal were colliding and sticking together, building up into the planets. The early Earth was not a gentle place. In these first hundreds of millions of years, our planet was constantly being bombarded. Rocks from space, some of them as large as cities, crashed into the surface over and over again. The heat from all of those collisions kept the surface of the Earth molten, a vast ocean of liquid rock glowing red and orange against a dark sky. There was no water on the surface yet. It was too hot. Any water that arrived would have immediately evaporated, turned to steam, and risen into the thick early atmosphere as vapour. But that vapour did not disappear. It stayed. It rose and thickened in the young atmosphere, and slowly, as the bombardment began to lessen and the surface began to cool, something remarkable happened. It rained. Not a gentle spring shower, not the kind of soft, misty rain you might hear on a roof late at night. This was something almost unimaginable. Billions and billions of gallons of water falling from the sky for thousands and thousands of years. A rain that never seemed to stop. A rain that slowly, gently, patiently filled the low places of the cooling rock. And that, in the most quiet and simple way, is how the first ocean was born. It is strange and beautiful to think about, is it not? That every drop of water in every ocean and every lake and every river and every glass of water you have ever held in your hand traces its story back to that ancient rain, to that cooling world, to that very first ocean. For a moment, just breathe. Feel the air move in and out of you. Notice how still the room is. You're safe here, and there is no rush. Scientists have a name for the earliest period of Earth's history. They call it the Hadean Eon. The name comes from Hades, the ancient Greek word for the underworld, the land beneath the living world. They gave it that name because the early Earth was so hot and violent that it seemed like a kind of fiery underworld compared to the gentle planet we know today. The Hadean Eon lasted from the formation of Earth, success, about 4.5 billion years ago, until roughly 4 billion years ago. That is 500 million years. 500 million years of a world forming itself, cooling slowly, being struck again and again by rocks from space, and somewhere in all of that finding its first water. We do not have many direct records of the Ediacaran Ocean. The rocks from that time have mostly been destroyed, melted down and reformed by billions of years of geological movement. The Earth is always slowly recycling its own crust, pulling old rock down into the deep interior and pushing new rock up at the edges of tectonic plates. But we do have clues. Small ancient mineral crystals called zircons have survived from those early days. Some of the oldest zircons ever found, discovered in a remote part of Western Australia, are over 4.4 billion years old. And when scientists study them very carefully, they find hints, chemical signatures, that suggest liquid water existed on the surface of the Earth, even that long ago. Even in the Hadean, there was already an ocean of some kind. It is humbling, in a soft and gentle way, to hold that idea. The oldest ocean on Earth might have existed over 4 billion years ago, and it left behind almost nothing except a few tiny crystals in an Australian desert, holding a quiet secret for all this time. Chapter 2. The Ocean. Before life. Let us drift now to a later time, not as early as the Hadean. We have moved forward a little into a period scientists call the Archean Eon, which lasted from about 4 billion years ago to 2.5 billion years ago. The world looks a little different now. The bombardment from space has slowed. The surface has cooled enough to form solid rock. There are land masses, though they are small and scattered, nothing like the great continents we know today. They are low, dark islands of volcanic rock rising just above the surface of a vast, endless ocean. And this ocean, this Archean ocean, is very different from any ocean alive today. Imagine you are floating above it, high up, looking down. The water stretches out in every direction, farther than you can see. There is no ice at the poles yet. The world is warmer than it is today, even though the sun is slightly dimmer. This sounds strange, but scientists think it is because the early atmosphere was thick with greenhouse gases, gases like methane and carbon dioxide that trapped heat close to the surface, like a warm blanket wrapped around the whole planet. The ocean is deep. In some places, perhaps even deeper than our modern oceans, and it is warm, especially near the shallow places near volcanic islands. But more than that, the chemistry of this ancient ocean is very different from the chemistry of the ocean we know. The water is not salty in the same way. It has iron dissolved in it, a great deal of iron, making it a slightly different colour. It lacks the oxygen that fills our modern ocean. Oxygen is a relatively new thing on Earth, as we'll see. The ancient ocean breathed differently, if you can say that a body of water breathes at all. And yet, somewhere in this warm, iron-rich, oxygen-free ancient sea, something extraordinary was happening. Life was beginning. No one knows exactly when the first living thing appeared on Earth. It is one of the deepest and most beautiful mysteries in all of science. We have fossils of microscopic organisms, tiny single-celled beings, from rocks about 3.5 billion years old. Some scientists think life may have begun even earlier, perhaps as far back as 3.8 or even 4 billion years ago. But we do not know exactly how. We do not know the moment. We cannot point to a rock and say, here, in this place, in this water, on this day, life began. What we do know is that it began in the ocean, almost certainly. The leading idea, the one that most scientists find most convincing, is that life first appeared near hydrothermal vents. These are cracks in the ocean floor where hot water, superheated by the volcanic rock below, pushes up through the seafloor carrying dissolved minerals and chemicals. Around these vents, even today, there are ecosystems full of strange creatures that live without sunlight, powered entirely by the chemicals coming from the deep earth. In the ancient Archean Ocean, these vents were probably even more common and more active than today. And the chemistry happening around them, the mixing of hot mineral-rich water with the surrounding cold ocean, may have created just the right conditions for the very first molecules of life to assemble themselves. Picture it. The deep, dark ocean floor 4 billion years ago. Absolute silence. No waves reaching this deep, no light from the sun. Just the faint glow of the hot vents, a soft orange and red in the darkness. And around those vents, in the warm mineral soup of that ancient water, the first tiny structures that would eventually become us were quietly, invisibly forming. It is a long, long distance from those first molecules to you, lying in your bed right now. Billions of years and countless generations, but the thread is unbroken. Every living thing on Earth traces its origin back to that ancient ocean, back to that warm, dark, mineral-rich water. You're made of ocean, very old ocean, and something about that is deeply, quietly comforting. For a moment, just breathe. You do not need to go anywhere right now. You do not need to do anything. The world outside is quiet. The night is soft. You're right where you're supposed to be. The first life forms were incredibly simple. They were single cells, much smaller than anything you could see with your bare eyes. No brain, no nervous system, no thoughts, just tiny living machines, taking in chemicals, making copies of themselves, and slowly, over millions and millions of generations, changing. These early microbes, called prokaryotes, lived in the ocean for a very long time. A very, very long time. In fact, for most of Earth's history, the ocean was ruled entirely by microscopic life. No fish, no jellyfish, no seaweed you could see with your eyes. Just tiny invisible creatures drifting in an ancient sea. And yet, even though we cannot see them, these tiny beings changed everything. They changed the ocean. They changed the sky. They changed the entire surface of the Earth. The most important group of early microbes were called cyanobacteria. You might not have heard that name before, and that is perfectly fine. Just picture a tiny, tiny creature, so small that billions of them could fit in a single drop of water. And imagine that this tiny creature had a remarkable ability. It could take sunlight and water and carbon dioxide from the air and use them to make energy. The same process that green plants use today, the process we call photosynthesis. And when cyanobacteria made energy this way, they released something as a byproduct, something that would slowly, over hundreds of millions of years, change the entire atmosphere of the Earth. They released oxygen. Chapter 3: The Great Oxygenation. This chapter of Earth's story is sometimes called the Great Oxygenation event, and it is one of the most important moments in the history of our planet. It happened around 2.4 billion years ago, though the process built up slowly over hundreds of millions of years before that. For billions of years, the atmosphere of Earth had very little free oxygen in it. The air was mostly nitrogen, with carbon dioxide, methane, and other gases. The ocean had very little dissolved oxygen either, but the cyanobacteria kept making oxygen. Generation after generation, trillion upon trillion of tiny cells, each one releasing a tiny puff of oxygen as they turned sunlight into energy. At first, the oxygen did not build up in the air. It was immediately absorbed by the iron dissolved in the ocean water and in surface rocks, combining with the iron to form iron oxide, which is just rust. This is why, when geologists look at rocks from this period, they find thick, beautiful layers of what they call banded iron formations, alternating stripes of iron-rich and iron-poor rock, ones you laid down on the ancient seafloor as the oxygen slowly reacted with the dissolved iron and sank to the bottom. For a long time, the ocean acted like a giant sponge, soaking up all the oxygen the cyanobacteria produced. But slowly the sponge filled up, the iron in the ocean was used up, and then the oxygen had nowhere to go except into the air. And when that happened, the world changed forever. For most of the creatures living in the Archean and early Proterozoic oceans, oxygen was not a gift, it was a poison. These ancient microbes had evolved in a world without oxygen. Oxygen was toxic to them, the same way carbon monoxide is toxic to us. When oxygen levels began rising, it may have caused one of the greatest extinction events in Earth's history, and killing off enormous numbers of the ancient anaerobic microbes that had dominated life for billions of years. But for other creatures, the ones that had evolved ways to use oxygen rather than be killed by it, this was an incredible opportunity. Oxygen is an enormously powerful energy source. Creatures that could breathe oxygen could extract far more energy from their food than creatures that could not. They could grow more, move more, think more, eventually. The rise of oxygen in the atmosphere was slow and not steady. It rose and fell over millions of years. But the long-term trend was upward, and each step upward opened new doors for life to walk through. If your eyes are heavy right now, that is perfectly fine. You do not need to keep up with every detail. Just let the words drift past you, like slow water moving around stones. Let them carry you gently. The story will still be here, and so will you. Notice your breathing for just a moment, in and out, slow and easy. The room is dark and safe. There's nowhere you need to be, nothing you need to do. Just rest and let the ancient ocean carry you. Now let us move forward in time again, not as quickly as before. We will take our time. We're in no rush tonight. We're going to step into the Proterozoic Eon, which lasted from about 2.5 billion years ago to about 538 million years ago. That is almost 2 billion years. Try to hold that number gently in your mind. 2 billion years. the age of the universe itself is only about 13.8 billion years. 2 billion years is not a small stretch of time. It is an enormous, deep, slow river of time, almost impossible to imagine. And for most of that 2 billion years, the ocean was still dominated by microbial life, bacteria, archaea, simple single-celled organisms drifting in warm or cold water, eating chemicals, eating sunlight, making oxygen, dying, falling to the seafloor, and building up layer after layer of sediment that would eventually become the rocks we study today. But something new was happening, slowly and quietly in those ancient seas. Cells were beginning to cooperate. Chapter 4: When cells learn to work together. This is one of the most mysterious and fascinating events in the history of life. Scientists call it endosymbiosis, which is a long word with a simple meaning. It means that one cell was swallowed by another cell, and instead of being digested, it survived inside the larger cell and became a partner. This sounds strange, maybe even a little unsettling. Yeah, but it happened, and it changed everything. The evidence suggests that around 2 billion years ago, a larger cell engulfed a smaller one, a bacterium that was already quite good at using oxygen to make energy. Instead of destroying the smaller cell, the larger one kept it alive. The smaller cell kept making energy inside the larger cell, and over many millions of generations, the smaller cell became so integrated that it could no longer survive on its own. It became what we now call a mitochondrion. Mitochondria are tiny structures inside almost every cell in your body right now. They are the power stations of your cells, the structures that take the food you eat and the oxygen you breathe and turn them into the energy your body uses for everything. And billions of years ago, they were free-living bacteria, swimming in an ancient ocean. There is a quietness to that idea that I find very beautiful. Right now, inside every cell of your body, there are ancient echoes of that Proterozoic ocean. Structures that trace their origin back 2 billion years, to a time when the continents looked nothing like they do today, and the sky above the sea was still learning how to hold oxygen. You carry the ocean inside you. You always have. These new cells with mitochondria and other complex internal structures, are called eukaryotes. Every plant, every animal, every fungus on Earth is made of eukaryotic cells. We're all descendants of that ancient moment of cooperation, when two cells became one. The first eukaryotes were still single-celled, still tiny and invisible, but they were more complex than anything that had come before. And with that complexity came new possibilities. Some of them began to gather together, to form loose clusters of cells that stayed attached to each other. Some of those clusters began to develop differences between cells, some cells doing one job, others doing another. This was the first faint beginning of what we call multicellular life. The first multicellular organisms were almost certainly very simple, thin sheets or strings of cells drifting in the ancient ocean, not much more complex than a thin piece of tissue paper. But they were there, and they were alive. For a long time, perhaps hundreds of millions of years, these simple multicellular organisms lived and died in the quiet Proterozoic ocean, leaving behind almost no fossil record. They were soft and had no hard shells or bones, yet nothing that could easily be preserved in rock. We know they existed mostly from chemical traces and from very rare, very special fossil sites, where even soft tissue was preserved. But then, at the very end of the Proterozoic, something began to change in the ocean, something that scientists have called, with a sense of quiet wonder, the Ediacaran Explosion. Chapter 5: The Garden of Soft Creatures. We are now approaching the end of the Proterozoic eon, about 600 to 540 million years ago. This period is called the Ediacaran, named after a place in South Australia called the Ediacara Hills, where some of the first fossils of these ancient soft-bodied creatures were found. Let me take you there, gently. Imagine you're floating just below the surface of a shallow, warm sea. The water is clear and still. There is no sound except the very faint movement of water, a soft swishing, almost like breathing. Above you, the sun filters through the water in long, pale beams. Below you, on the seafloor, something extraordinary is growing, creatures unlike anything alive today. Some of them look like round discs, flat against the seafloor, with faint rings like the rings of a tree trunk. Some look like long, quilted fronds, anchored to the mud by a stem, waving very gently in the current. Some look like nothing you could compare to anything familiar, shapes that seem to follow their own rules, their own geometry, their own quiet logic. These are the Ediacaran biota, the world's first complex multicellular organisms visible to the naked eye. They had no eyes, no mouths as far as we can tell, no brains. Why, most of them probably absorbed nutrients directly from the water around them, or from the microbial mats, thick carpets of bacteria that covered the seafloor in those ancient times. They were peaceful, passive, slow-moving, or completely stationary. They lived in a world without predators. There was nothing that hunted them. The ocean was quiet and safe and slow, like a garden that no one had yet come to disturb. Some scientists have called this the Garden of Ediacara. Not a threatening, competitive ecosystem like our modern oceans, full of things eating other things, but something gentler and stranger, a world of soft shapes drifting and growing in a quiet sea, as if the ocean were simply experimenting, trying out forms of life, seeing what was possible. The Ediacaran organisms are one of the great mysteries of paleontology, the science of ancient life. We still do not fully understand what they were. Some of them may be the ancestors of animals alive today. Others may be completely separate branches of life, experiments that did not survive into the Cambrian period that followed. Some may not be animals at all in any sense we would recognise. What we do know is that they existed. They left their shapes in the rock, pressed like soft stamps into the ancient seafloor mud. And when you look at those fossils, those round discs and frond-like shapes preserved in stone for over 500 million years, there is something deeply moving about them, something quiet and wondering. These were the first living things large enough to see, the first living things you could have held in your hand if you had been there, the first living things that had a shape, a visible presence in the world. And then, around 540 million years ago, the world changed again. But that is a story for the next part of our journey. For now, let us rest here, in the Ediacaran Ocean. Let us float above that quiet seafloor, above those strange soft shapes anchored to the mud, drifting in that ancient current. The sun is filtering down through clear water. There is no hurry. There is no threat. There is only the slow, gentle breathing of a world that is still becoming itself. Let your body sink a little heavier into wherever you are resting. Let your arms and legs feel soft and heavy. Let your jaw unclench. Let your forehead smooth and relax. You have travelled a long way tonight, from the formation of the first ocean in the Hadean, to the iron-rich Archean Sea, to the slow oxygenation of the world, to the first complex cells cooperating, to the quiet garden of Ediacaran creatures on an ancient seafloor. And we have only just begun. There are more oceans to visit, older mysteries to drift through, more chapters of this long, slow, beautiful story, but for now, just rest. Let these ancient waters hold you. Let the image of that quiet Ediacaran garden stay with you as you breathe, in and out, soft and slow. The world turns slowly, and so do we. If you are already asleep, that is perfectly fine. This story will still be here when you wake. The ancient ocean will still be waiting, patient as it has always been. And if you are still with me, still drifting in that soft space between waking and sleep, I am glad. We will continue this journey together, slowly, gently, all the way to the end. We left the Ediacaran Ocean behind us, that quiet garden of soft shapes on the ancient seafloor. We left behind the round discs and the frond-like creatures, anchored gently in the mud while the world above them slowly, slowly changed. Now we move forward, not quickly, never quickly. We drift forward the way a current moves deep beneath the surface, slow and steady, and almost impossible to feel unless you're very still. Tonight we're going somewhere new. We're going to the moment when the ocean woke up. Maybe you are still in the same position you were when we started. Maybe you have shifted, turned onto your side, pulled the blanket a little closer. That is good. Get comfortable. Let your body find its easiest, softest arrangement. There is a long, gentle night ahead of us, and all you need to do is breathe and listen. Picture a sky just before sunrise, and not fully dark but not yet light. That in-between colour, the deep blue-grey that exists only in those quiet moments before the world wakes up. Now imagine that feeling, but stretched across millions of years. That is what the late Ediacaran Ocean was like. Life was there. Life had been there for billions of years, but it was quiet, soft, slow. The ocean was full of living things, but they were simple, passive, unhurried. And then, around 538 million years ago, the sun rose. Not a real sun. I mean, something happened in the ocean, something scientists are still debating and studying and wondering about, that caused an explosion of new life forms unlike anything that had come before. In a relatively short period of geological time, which still means millions of years, but short compared to the billions we have been talking about, thus the ocean filled with new kinds of creatures, creatures with eyes, creatures with mouths, creatures with shells and claws and legs, creatures that moved and hunted and hid and chased. The quiet garden of Ediacara was over. A new world had begun. Scientists call this event the Cambrian Explosion, and it is one of the most astonishing chapters in the entire history of life on Earth. The Cambrian period lasted from about 538 million years ago to about 485 million years ago. 53 million years. And the ocean during that time was, by any measure, one of the most strange and spectacular environments that has ever existed on this planet. Let me take you there. Imagine you are hovering just beneath the surface of a warm, shallow sea. The water is clear and lit by golden light from above. Below you, the seafloor is not bare rock or grey mud. It is alive. It is covered in a dense, complex community of creatures unlike anything in any modern aquarium or documentary you've ever seen. There are creatures with 5 eyes and a single grasping claw at the front of their bodies, reaching out to grab small prey. There are creatures that look like living shrimp the size of your arm, gliding through the water with rippling fins along their sides. There are creatures shaped like spinning tops, armoured with overlapping plates. There are soft, worm-like things burrowing into the sediment. There are tiny creatures in elegant cone-shaped shells. There are flat, spiny things crawling slowly across the seafloor. And everywhere, motion. Everywhere, life doing something. Hunting, hiding, filter feeding, burrowing, swimming. For 3 billion years before this, the ocean had been a place of quiet, mostly invisible life. Now, suddenly it was full of visible, complex, active animals. Something had changed. But what? Scientists have many ideas about why the Cambrian explosion happened, and the honest answer is that we do not fully know. Most likely it was a combination of things, all coming together at just the right time. One important factor was oxygen. By the Cambrian period, Oxygen levels in the atmosphere and ocean had been slowly rising for a long time. Higher oxygen levels allowed for more complex metabolisms, the ability to grow larger bodies, to move more, to be more active. Simple bodies do not need much oxygen. Complex active bodies need a great deal of it. Another factor was the development of eyes. This might seem small, but it was enormous. Once one creature in the ocean developed the ability to detect light and form even a basic image of its surroundings, everything changed. If you can be seen, you can be hunted. And if you can be hunted, there is pressure to evolve defenses. And if there are defenses, there is pressure to evolve better hunting. This arms race, this back and forth between predator and prey, may have driven much of the rapid diversification we see in the Cambrian. The development of hard shells and armour was a direct response to predation. Before the Cambrian, hard body parts were almost unknown in the fossil record. Then, quite suddenly, they appear everywhere. Shells, spines, plates, claws, all of it arising in a relatively short time, as if the ocean suddenly decided that soft bodies were no longer safe, and perhaps they were not. The creature that many people think of as the great predator of the Cambrian Ocean is called Anomalocaris. Its name means abnormal shrimp, which is a wonderfully understated name for an animal that was the largest predator of its day. Anomalocaris could grow to about 1 metre in length, which does not sound very large to us, but in the Cambrian Ocean, where most creatures were measured in millimetres or centimetres, it was enormous. It had large, compound eyes, the kind made of many tiny lenses, like the eyes of a modern fly but far more sophisticated. It had 2 grasping appendages at the front of its head, ringed with spines, perfect for catching and holding prey. And it had a circular mouth with overlapping plates that could bite and crush. It was, by any measure, a remarkable animal. And it moved through the Cambrian Ocean with a kind of easy, quiet authority, its body rippling as it glided through the water. There is something almost dreamlike about imagining it. This creature, swimming in a warm, ancient sea over 500 million years ago, under a sky that looked different from our sky, above a seafloor covered in life forms that no longer exist anywhere on Earth. Gone now, completely gone. Only its fossils remain, pressed into stone in places like the Burgess Shale in Canada and the Chengjiang beds in China, waiting to be found by patient scientists with small brushes and careful hands. The Burgess Shale is one of the most important fossil sites in the world. It is located high in the Canadian Rockies, in the mountains of British Columbia. It is cold there now and remote, with thin air and a sky that seems very close. But about 508 million years ago, this place was at the bottom of a shallow tropical sea. The fossils preserved there are extraordinary. Because of the particular way the sediment was deposited, soft body parts were preserved along with hard ones. This means that scientists have found not just shells and bones, but impressions of guts, eyes, gills, and muscles, things that almost never survive in the fossil record. It gives us a window into the Cambrian Ocean that is almost impossibly detailed, an entire snapshot of a community of creatures frozen in time by a long ago mudslide that quickly buried them and sealed them from decay. Looking at those fossils is like looking at a photograph. A very, very old photograph taken without a camera by the patient geology of the Earth itself. For a moment, just breathe. Let the image of that ancient sea rest in your mind, the warm water, the strange creatures moving through it, the distant sound of nothing in particular, just the soft shifting of water and sediment, the quiet hum of an ocean doing what oceans do. If your eyes are already closed and your thoughts are becoming softer and less distinct, that is exactly right. You do not need to hold on to every detail. Just drift. The story will carry you. Your breathing is slow. Your body is heavy. The night is quiet and the world outside is very far away. Chapter 7. The Ocean. After the first animals, let us drift forward in time once more. We are leaving the Cambrian behind, not because there is nothing more to say about it, there is so much more, but because our journey tonight is long and gentle, and there are many more oceans waiting for us ahead. We move into the Ordovician period, which lasted from about 485 million years ago to about 443 million years ago. 42 million years, another deep, slow stretch of time. The Ordovician Ocean was in many ways even more spectacular than the Cambrian. If the Cambrian was the dawn, the Ordovician was the early morning, bright and growing brighter by the hour. The Cambrian Explosion had introduced the basic body plans of most modern animal groups. Now those body plans were diversifying, spreading, filling every available niche in the ocean. Life was experimenting at an astonishing rate. The Ordovician Ocean was warm. There were no polar ice caps for most of this period. Sea levels were high, much higher than today, and shallow inland seas covered large parts of what are now continents. In North America, a vast warm shallow sea stretched across most of what is now the central part of the continent, from what would one day be Tennessee to what would one day be Manitoba. A sea where there is now dry land, where there are now farms and cities and highways. It is strange and peaceful to think about. Under the streets of certain cities in the middle of North America, deep in the rock, there are fossils of creatures from this ancient sea. Coral, shellfish, echinoderms, sea creatures preserved forever in the rock beneath a continent that did not yet exist. The creatures of the Ordovician Ocean were diverse and remarkable. Trilobites, which had first appeared in the Cambrian, were still present, but now they came in hundreds of new species. Some had elaborate horns and spines, some were tiny, barely a few millimeters long, some were large and heavily armoured. They crawled along the seafloor, swam in the water column, and burrowed in the sediment. Nautiloids were common in the Ordovician Ocean. These were relatives of the modern nautilus, a beautiful creature that still exists today, living in its elegantly spiraled shell in deep tropical waters. But the ancient nautiloids were often very different in shape. Some of them had straight cone-shaped shells, not spiraled at all, and some of these straight-shelled nautiloids grew to enormous sizes, perhaps 3 or 4 meters long. They were the apex predators of the Ordovician Ocean, drifting through the water with their tentacles trailing below them, hunting with slow, patient intelligence. There was also, in the Ordovician Ocean, the beginning of something that would become one of the defining features of our modern ocean: coral reefs. The first true reefs in Earth's history formed during the Ordovician. Not exactly like modern coral reefs, which are built by animals called stony corals that did not yet exist. These early reefs were built by different organisms, tabulate corals and stromatoporoids, creatures that are now extinct. But the principle was the same: small creatures building hard calcium structures one on top of another, year after year, century after century, until a vast solid structure rose from the seafloor toward the surface. These ancient reefs were hubs of life, just as modern reefs are. Other creatures sheltered in them, fed around them, hid in the crevices between the coral heads. In a reef, every surface is occupied. Every gap is a home for something. Imagine drifting slowly through one of those Ordovician reefs, the light filtering down from above, catching the edges of the coral in pale gold. The water is very clear. All around you, creatures you do not recognize move through the water and across the reef surface. There is no hurry here. Everything moves at its own slow pace. A large nautiloid drifts past in the middle distance, its long, pale shell glowing faintly in the filtered light. It does not seem to notice you. It is thinking its slow, ancient thoughts, following some quiet instinct toward the smell of prey somewhere in the current ahead. Below you, on the reef surface, a cluster of crinoids, creatures like underwater flowers, long-stemmed, with feathery arms spread wide to catch food particles drifting in the current, sways gently in the water movement. Their stems are anchored to the reef. Their arms move constantly but slowly, like something breathing. Everything is alive, everything is connected, and yet everything is so quiet. This is the Ordovician Ocean. This is what it felt like, perhaps, to exist in that ancient sea. But the Ordovician Ocean would not last forever. Nothing lasts forever, as this story keeps reminding us. Toward the end of the Ordovician period, about 443 million years ago, something happened that would end this flourishing world. Something that scientists call the late Ordovician mass extinction. It was one of the 5 largest mass extinction events in Earth's history, and it killed somewhere between 60 and 70% of all marine species alive at the time. The leading cause was glaciation, ice. For reasons that scientists are still studying, the climate of the Earth shifted dramatically at the end of the Ordovician. A vast ice sheet formed over the southern polar region, covering what is now Africa and parts of South America with glaciers. Sea levels dropped dramatically as enormous amounts of water were locked up in ice. The shallow inland seas drained away. The warm, stable conditions that had allowed the Ordovician reef systems to flourish were suddenly replaced by cold, changing, unstable conditions. For the creatures that lived in those warm, shallow seas, the change was catastrophic. Many species of trilobites disappeared. Many nautiloids vanished. Many of the reef-building organisms died out entirely. The Great Ordovician reefs, which had taken millions of years to build, were destroyed. It is a sad chapter, but it is also, in the long view of deep time, a necessary one. Because every extinction creates space. Every ending is also a beginning. The species and ecosystems that survived the late Ordovician extinction would diversify and spread into the empty niches left behind, filling the ocean with new forms of life, new experiments, new possibilities. This is something we will see again and again in the story of the ancient oceans: destruction and renewal, walking alongside each other through the long corridor of time. Chapter 8: The Age of Fishes. Let us rest here for just a moment before we continue. Notice how your body feels right now. Are your arms soft and heavy? Are your legs relaxed? Your feet loose? Is your breathing low and slow, rising and falling gently? If you have drifted off and are hearing this in that soft half sleep, where sounds become part of a dream, that is beautiful. Let it happen. The ocean is still here. The story is still here. You can float in and out of it as you please, and if you're still awake, still following the slow current of this narrative, then let us drift forward once more into the Silurian and Devonian periods, into the time that paleontologists sometimes call the Age of Fishes. The Silurian period lasted from about 443 million years ago to about 419 million years ago. After the devastation of the late Ordovician extinction, life slowly recovered in the ocean. New species evolved to fill the spaces left by the ones that had died. Coral reefs returned. Built now by new kinds of organisms, trilobites were still present, still diverse. Cephalopods, the group that includes the ancient nautiloids, were still swimming through the ocean. But something new was happening. Something that would eventually change not just the ocean, but the entire surface of the Earth. Fish. The first fish-like creatures had actually appeared during the Cambrian small, jawless, soft-bodied animals that swam by, wiggling their bodies from side to side. But in the Silurian and then the Devonian, fish truly came into their own. They diversified explosively. They developed jaws, which was an enormous evolutionary innovation. Jaws allowed fish to eat in ways that jawless creatures could not. They could bite, they could crush hard-shelled prey, they could eat other fish. The Devonian period, which lasted from about 419 million to about 358 million years ago, is sometimes called the Age of Fishes because of how spectacularly fish diversified during this time. The Devonian Ocean was full of fish of every conceivable shape and size. There were the placoderms, armoured fish with heavy bony plates covering their heads and front portions of their bodies. Some placoderms were small and gentle, filter feeders or bottom dwellers. But one group, the Dunkleosteus, was anything but gentle. Dunkleosteus was one of the most formidable predators that has ever lived in any ocean at any time. It could grow to about 6 meters in length. Its head was encased in heavy interlocking bony armour. Instead of teeth, it had shearing bony plates that formed a scissor-like bite, among the most powerful bites of any fish that has ever lived. No, it did not sneak up on its prey. It didn't need to. It simply swam, massive and armoured and slow, through the Devonian Ocean, and whatever was in its path either fled or was eaten. There is something awe-inspiring about Dunkleosteus. Not frightening, not from the safe distance of 375 million years, just impressive. A reminder that nature, given enough time and the right conditions, can produce shapes and scales of life that we could never have imagined if we had not found them in the rock. The Devonian Ocean was also home to the ancestors of a group that would eventually include us. In the shallow, weedy, warm waters of the Devonian, some fish were developing something unusual. Fins that were lobed and muscular, more like limbs than like the thin, flat fins of most fish. These lobe-finned fish could prop themselves up on these fins, push themselves through very shallow water, even drag themselves short distances across mud. They were not trying to leave the ocean. They had no ambitions about land. They were just fish, doing what fish do, moving through the water in search of food and shelter. But the world was changing around them, and those muscular fins would eventually become the legs that carried the first vertebrates onto dry land. The journey from fish fin to human hand is a long one, measured in hundreds of millions of years, but it began in the warm, shallow waters of the Devonian Ocean, in a fish that was just trying to get from one pool to another. And if that does not make you feel a soft, quiet sense of connection to the ancient world, I do not know what will. Let us rest in the Devonian Ocean for a moment. The water is warm, the light is golden, and filtering down through water that is shallow and clear near the shore, schools of small fish drift past in loose formations, turning all at once, their scales catching the light. Somewhere in the deeper water, slow and patient, a Dunkleosteus circles. On the muddy seafloor near the shore, the first simple plants have begun to grow in the water near the edge, and beyond the water, on the bare land that was once completely lifeless, something green and small is beginning to creep. Life is reaching for the shore. Life is always reaching. But that is a story for another time. Sleep reset. If you are still awake, I want you to take a slow, deep breath. In through your nose, slow and easy. Hold it for just a moment, and then let it out, slow and steady. All the way out. Again. Breathe in, hold gently, breathe out. Let your whole body exhale, not just your lungs, but your shoulders, your jaw, your hands. Let everything go soft. You've been travelling through deep time tonight, through billions of years of ocean history, through the first rain, the first life, the first animals, the first reefs, the first fish. It is a lot to carry, even gently, so let it settle now. Let it rest in some quiet corner of your mind, soft and still. If your eyes are heavy, close them. If they are already closed, Let them stay that way. The story will continue, the ancient ocean will still be here, and so will you. The world turns slowly, and so do we. Chapter 9. The Great Devonian Dying. There is a pattern in the story of prehistoric oceans. Life grows and diversifies and fills every corner of the sea, and then something changes, and much of it dies. Not all of it. Never all of it. Life has proven again and again that it cannot be fully erased from this planet. No matter how severe the extinction, something always survives. Something always crawls out from beneath the rubble of the old world and begins, slowly and quietly, to build the new one. But the extinctions are real. They happened, and the late Devonian extinction, which occurred roughly 375 to 359 million years ago, was one of the most severe in Earth's history. Over the course of several million years, somewhere between 70 and 80% of all species on Earth went extinct. The marine ecosystems that had been building and diversifying for over 100 million years were devastated. The Great Devonian reef systems, which had been even more extensive and diverse than those of the Ordovician, collapsed almost entirely. The placoderms, those remarkable armoured fish that had ruled the Devonian Ocean, were almost completely wiped out. Only a handful of lineages survived into the next period. Dunkleosteus and its kind disappeared forever. Trilobites, which had survived the Ordovician extinction and recovered through the Silurian and Devonian, were hit hard again. They would survive into the next period, but much diminished, a ghost of their former diversity. What caused the late Devonian extinction? As with all mass extinctions, the answer is probably a combination of factors, and scientists are still debating the details. One important factor seems to have been the rapid expansion of land plants. During the Devonian, plants had begun to colonize the land in a serious way. The first true forests appeared, with trees that had deep root systems. And those root systems did something important. They broke down rock much faster than bare rock weathered on its own. This released large amounts of phosphorus and other nutrients into rivers and eventually into the ocean. Too many nutrients in shallow ocean water is not a good thing. It causes explosions of algae, massive blooms that can deplete the oxygen in the water when the algae eventually die and decompose. Ocean waters can become anoxic, meaning they have very little or no dissolved oxygen. And when that happens, most complex marine life suffocates and dies. This process, called eutrophication, may have been a major cause of the late Devonian extinction. The very success of life on land, the spread of forests and root systems across the continents, may have poisoned the ocean for much of the life within it. There is a strange irony in that. Life helping to destroy life, the land reaching out and without intention, without malice, harming the sea. But again, not everything died, and what survived would grow and change and fill new niches, because that is what life does, quietly and persistently, through all the long deep years of time. Chapter 10. Between Extinctions. The Carboniferous Sea. We are moving now into the Carboniferous period, roughly 358 to 298 million years ago, 60 million years, another long, slow river of time. The name Carboniferous comes from the Latin word for coal. This period is when the great coal deposits of the world were laid down, the forests that fell and were buried and slowly compressed over millions of years into the black rock we burn for energy today. When you hold a piece of coal, you are holding the compressed remains of a carboniferous forest, 300 million years old. But while those forests were growing on land, the ocean was doing its own quiet work. The marine extinction of the late Devonian had cleared the stage. Now new actors were taking their places. Sharks, which had first appeared in the Devonian and survived the extinction, diversified significantly in the Carboniferous. The Carboniferous Ocean was home to a remarkable variety of sharks, some of them very different from any sharks alive today. There was one called Helicoprion, which had a bizarre spiral of teeth in its lower jaw, like a circular saw. There was Stethecanthus, a shark with an extraordinary anvil-shaped structure on its back, like a dorsal fin that had been flattened and covered in tiny scales, the purpose of which we still do not fully understand. The ocean was also home to vast numbers of crinoids, those sea lily creatures we met briefly in the Ordovician. In the Carboniferous, they were so abundant that their fossilized remains make up a significant fraction of certain limestone deposits. They carpeted the seafloor in some places, a waving forest of long stems topped with feathery arms, each one filtering food particles from the water. Imagine sinking slowly down through the Carboniferous Ocean, descending from the sunlit surface toward the seafloor. The water grows dimmer and cooler as you go deeper, and then as you approach the bottom you see it, a vast, dense meadow of crinoids stretching in every direction as far as you can see. Their stems sway in the gentle current. Their arms, spread wide, move in slow, as synchronized waves, as if they are all breathing together, all part of one enormous quiet organism. Between the crinoid stems, other creatures move, small fish, trilobites, still here, still crawling through the sediment, though fewer in number and less diverse than before. Ammonites, the coiled cephalopods that would become so abundant in the Mesozoic, are beginning to appear, their elegant spiral shells drifting through the water. It is a calmer, quieter ocean than the Devonian, recovering, rebuilding, slowly filling with new forms of life in the spaces left by the old ones. This is what oceans do after catastrophe. They rest, they rebuild, they fill themselves with new life, patient as the tides, persistent as the deep current that moves unseen beneath the surface. The Carboniferous was followed by the Permian period, from about 298 to 252 million years ago. The Permian Ocean was, in many ways, one of the most diverse and complex marine ecosystems Earth had ever seen. Brachiopods, shellfish-like animals that superficially resemble clams but are not related to them, dominated the seafloor in vast numbers. Bryozoans, tiny colonial animals that built intricate calcium structures, formed reef-like mounds. Ammonites were abundant and diverse. Sharks of many kinds patrolled the water. It was a rich, complex, thriving ocean, in some ways the most fully realized version of the ancient marine world. And then, 252 million years ago, it was almost completely destroyed. But that chapter, that great and terrible chapter, is waiting for us in part 3 of our journey. For now, let us rest here, in the warm, crinoid-carpeted Carboniferous Sea. Let us float above that meadow of slow, swaying creatures. Let the dim, filtered light settle over us. Let the gentle current move us without effort or intention. You've been travelling so far tonight, through billions of years, through the first ocean, through the Cambrian Explosion, through the age of fishes, through 2 mass extinctions, through the slow recovery of life after each one. You're safe. You are warm. The night is quiet and the world outside is still. Let your breathing be slow. Let your thoughts drift apart from each other, like clouds spreading out in a clear sky. If you are asleep, I am glad. Sleep is a good and gentle thing. Rest your mind in the warm Carboniferous Sea, and let the ancient water hold you until morning. If you are still here with me, still drifting in that soft space between waking and dreaming, then close your eyes a little more. Let the images go soft. Let the facts fade into feeling. Let the ancient ocean become not a thing you know, but a thing you sense. We will continue this journey. The story has more to give. The forgotten oceans of prehistoric Earth are deep and wide, and we have only just begun to cross them. But for now, the current is gentle, the water is warm, and there is no need to go anywhere at all. The world turns slowly, and so do we. We left the Carboniferous Ocean behind us, that quiet meadow of crinoids swaying in the deep, dim water, that recovering world slowly filling itself back up with life after the devastation of the Devonian extinctions. Now we move forward once more, gently, without hurry. We are drifting toward one of the most dramatic moments in the entire history of life on this planet. Yeah, a moment so vast and so final that scientists simply call it the Great Dying. But before we get there, let us settle in. Let us get comfortable. Maybe you have been listening for a while now. Maybe your body is very heavy and warm. Maybe the room around you has disappeared almost entirely, replaced by the soft, slow images of ancient seas. That is exactly where I want you to be. That dim, gentle place between the waking world and the dreaming one. Take a slow breath. In, soft and easy. Out, slow and complete. Let our hands go loose. Let your face go soft. Let the weight of the day drain away from you, like water running slowly off a smooth stone. We're going somewhere very old tonight, and all you need to do is drift. The Permian Ocean, as we left it, was one of the most diverse and thriving marine ecosystems the Earth had ever produced. Brachiopods covered the seafloor in vast numbers. Ammonites drifted in elegant spirals through the open water. Sharks hunted quietly in the deeper zones. Coral reefs, rebuilt after the Devonian catastrophe, rose again from the seafloor toward the light. It had taken life almost 100 million years to build this world. 100 million years of slow diversification, of filling every crack and crevice of the ocean with a living thing shaped just right for that particular place. And then, 252 million years ago, it ended. Not slowly, not gracefully. In geological terms, it ended almost instantly. Scientists call this event the Permian Triassic extinction event, but it is more commonly known as the Great Dying, and it earns that name. It was the largest mass extinction in the history of complex life on Earth. Not the most famous. The asteroid that killed the dinosaurs tends to get more attention, but by far the most severe. Estimates vary, but the Great Dying may have killed somewhere between 90 and 96% of all marine species alive at the time. Think about that number for a moment. Not a third, not half. 9 out of every 10 species in the ocean, gone. Perhaps even more. The ocean, which had been so rich and so full of life, became almost empty. What caused it? The leading cause, the one that most scientists now agree on, was a series of volcanic eruptions of almost incomprehensible scale. In what is now Siberia, in northern Russia, an enormous region of the Earth's crust cracked open and began releasing lava in volumes we have no modern equivalent for. These eruptions, which scientists call the Siberian traps, continued for perhaps 1 million years. They poured out lava that covered an area roughly the size of Europe, but the lava itself was not the main killer. It was what the eruptions released into the atmosphere. Enormous volumes of carbon dioxide, enormous volumes of sulfur dioxide, enormous volumes of methane, released as the lava burned through thick deposits of ancient organic material in the rock. The carbon dioxide caused rapid, severe global warming. Ocean temperatures rose dramatically. Warm water holds less dissolved oxygen than cold water, and so the ocean began to suffocate. Large portions of the ocean became anoxic, meaning they had almost no oxygen at all. At the same time, the carbon dioxide dissolved into the seawater and made it more acidic. The ocean acidification dissolves calcium carbonate, the material that shells and reefs are made of. Creatures that built shells, creatures that built reefs, creatures whose entire existence depended on being able to maintain their calcium structures in the water, found their shells dissolving around them. The warming ocean also produced enormous releases of methane from the seafloor, where methane had been stored in frozen deposits for millions of years. This methane, a powerful greenhouse gas, caused further warming, which caused further methane release, in a runaway cycle that made things even worse. The ocean became hot, acidic, and suffocating, and life in it collapsed. There is something very still and quiet about trying to imagine the Permian Ocean in its last days. Not dramatic, not loud, just a slow fading. The brachiopods dying in their shells, the ammonites declining until the water column holds fewer and fewer of their beautiful spirals, the reefs bleaching and dissolving, the seafloor becoming covered in a thick dark layer of sediment with almost nothing living in it. A geologist looking at a core of rock from this period can see it clearly. Below the boundary, a rich and varied layer full of fossils, full of the traces of life. Above the boundary, almost nothing. A grey, empty layer that speaks of a world that had lost most of its living inhabitants. Scientists call this layer the boundary clay. It is thin, sometimes only a few centimetres thick. But those few centimetres represent perhaps 50,000 years of death. 50,000 years during which the ocean was so changed, so hostile, that almost nothing could survive in it. Then slowly, from that almost empty sea, life began again. Chapter 12. The Long Recovery. The Triassic period began about 252 million years ago, in the wake of the Great Dying. And for the first several million years of the Triassic, the ocean was quiet and nearly empty. Not completely empty. Life had survived, as it always does, in small pockets, in deep cold water, in isolated corners where conditions were slightly better. Some species of brachiopods made it through, some mollusks, some fish. The ancestors of modern corals, a group of organisms called scleractinian corals that would eventually build every reef in the modern ocean, appear to have evolved in the aftermath of the extinction, filling the niche left by the reef builders that had died. Recovery from a mass extinction is always slow. Not just because life needs time to evolve new species, though it does, but also because the ocean itself needs time to recover its chemistry, to cool down, to restore its oxygen levels, to become hospitable again. For the first few million years of the Triassic, estimates suggest that recovery was very slow. Then, gradually it began to accelerate. Ammonites, which had nearly gone extinct in the Great Dying, recovered with remarkable speed. Within a few million years of the extinction, they were diversifying again, filling the water column with new species of beautifully coiled shells. Ammonites would go on to become one of the defining creatures of the Mesozoic era. So abundant and so diverse that scientists use them as index fossils, precisely dated markers for identifying the age of rock layers around the world. Marine reptiles began to appear. Animals that had originally evolved on land were returning to the sea, their limbs gradually transforming into flippers over millions of generations. The Triassic Ocean was in the process of becoming something new. For a moment, just breathe. Let your body sink a little heavier. Let the darkness behind your eyes become softer and deeper. Let the story become something you feel rather than something you follow. The ancient ocean is very patient. It has been here for billions of years, and it will be here long after this night is over. It does not need you to pay attention. It does not need you to understand every detail. It just needs you to rest in it for a while. You're doing that beautifully. If you're drifting towards sleep right now, let yourself go. There is nothing to hold on to, nothing to stay awake for. Just soft, warm darkness and the distant sound of very old water moving slowly in the deep. The world turns slowly, and so do we. There is an ocean that does not exist anymore, an ocean that has been gone for tens of millions of years, and yet it shaped the world we live in more profoundly than almost anything else in geological history. Its name is the Tethys Sea. The Tethys was not a small sea. At its greatest extent, it was an enormous body of water, warm and shallow and rich with life, stretching across the equatorial region of the Earth for hundreds of millions of years. It was, in a very real sense, the ocean at the centre of the ancient world. To understand the Tethys, we need to understand something about how the continents move. The surface of the Earth is not fixed. Then it sits on top of a mantle of slowly moving rock, and the plates of crust that make up the continents and ocean floors drift very slowly, only a few centimetres per year, but given enough time, a few centimetres per year becomes thousands of kilometres. Continents that were once joined drift apart. Continents that were once separate slowly collide. Oceans open. Oceans close. This process is called plate tectonics, and it has been reshaping the surface of the Earth for billions of years. During the late Paleozoic era, all of the world's continents were joined together in a single supercontinent that geologists call Pangaea. Imagine all of the land on Earth gathered into one enormous mass, surrounded by a single global ocean. The supercontinent stretched from pole to pole. It was so large that its interior was far from any ocean, creating vast, dry, continental deserts in its centre. The global ocean that surrounded Pangaea is sometimes called Panthalassa, from the Greek words meaning all sea. It covered most of the Earth's surface, a vast and largely featureless deep ocean, much less diverse than the shallow water environments that have been home to the rich Paleozoic marine ecosystems. But on the eastern side of Pangaea, a great bay or inlet opened up between the northern and southern portions of the supercontinent. This was the early Tethys Sea, a warm, tropical, shallow body of water sheltered on three sides by the supercontinent, open to the Panthalassa Ocean on the east. As Pangaea slowly began to break apart, starting in the Triassic and continuing through the Jurassic, the Tethys grew. The northern landmass, which scientists call Laurasia, and the southern landmass, which they call Gondwana, drifted slowly apart, widening the Tethys between them. By the Mesozoic era, the Tethys was one of the great oceans of the world, warm, wide, shallow in many places, rich with life. The Tethys Sea is where many of the creatures we think of as quintessentially Mesozoic made their home. Ichthyosaurs, those dolphin-shaped marine reptiles that evolved from land-dwelling ancestors and returned to the sea, swam in the Tethys. Plesiosaurs, with their long necks and broad bodies and four flipper-like limbs, hunted fish in its warm waters. Mosasaurs, the great sea lizards of the late Cretaceous, patrolled its depths. Ammonites, by now extraordinarily diverse, filled the Tethys with an almost unimaginable variety of forms. Some ammonites were small, the size of a coin. Others were enormous, as large as a car tyre or even larger. Some had tightly coiled shells. Some had loosely coiled or even uncoiled shells, strange corkscrew shapes or gently curved rods. They were everywhere in the Tethys, so numerous that their fossilized shells litter the rock of every continent that was once washed by that ancient sea. Let me take you there, gently. Imagine you are floating just below the surface of the Tethys Sea, perhaps 150 million years ago, in the middle of the Jurassic period. The water is very warm. It is clear and blue-green, lit from above by a tropical sun. The surface is just a metre above your head, and through it you can see the bright, wavering light of a warm day. Below you, the seafloor is perhaps 20 or 30 metres down, visible in the clear water. It is covered with coral, with sponges, with long-spined sea urchins moving slowly across the reef surface. Schools of small fish dart in and out of the coral, quick and silver in the light, something large moves past you in the middle distance. Long, smooth body, 4 broad flippers working slowly through the water, a neck that stretches forward, impossibly long, tapering to a small head that turns toward you for just a moment before the creature glides past and disappears into the blue-green depth. A plesiosaur. Moving through its world with calm, unhurried grace, you watch it go. You watch until it is just a dim shape in the deeper water, and then it is gone. And the Tethys is quiet again, warm, clear, alive with small sounds and small movements, a world going about its business as it has done for millions of years, as it will do for millions more. The Tethys Sea did not vanish all at once. Like the continents themselves, it changed slowly over tens of millions of years. As the continents drifted, as India moved northward toward Asia, as Africa moved northward toward Europe, the Tethys was gradually squeezed and compressed. The sediments that had accumulated on the floor of the Tethys, millions of years of compressed shells and coral and seafloor mud, were pushed upward as the continents collided. They became mountains. The limestone of the Alps, the marble of certain Italian mountains, the ancient seafloor rock of the Himalayas, these were all once the floor of the Tethys Sea. When you look at a photograph of the Alps, with their jagged snow-covered peaks rising against a clear sky, you're looking at the fossilized remains of a vanished ocean. The rocks of those mountains are full of ancient marine fossils, ammonites and shells and coral, now lifted miles above sea level, preserved in stone that was once deep under warm tropical water. The Tethys is gone now, but it is not entirely gone. Small remnant seas, the Mediterranean, the Black Sea, the Caspian Sea, are all that remain of that great ancient ocean, diminished, changed, separated from each other, and from the world ocean by the land that grew up around them. They are the last quiet echoes of the Tethys, the last soft reminders of an ocean that shaped the world we live in, and then slowly, gently, over millions of years, disappeared beneath the mountains it had helped to build. There is something deeply peaceful about that idea. An ocean becoming a mountain, water becoming stone, the seafloor becoming a summit. When nothing is permanent, everything changes, but everything also leaves something behind. The Tethys left its fossils in the rock, it left its chemistry in the stone, it left its memory in the sediment of the world, just as you, in your own small way, leave traces in the people who know you, in the things you've made and said and done, in the quiet moments of kindness and presence that you may not even remember. Nothing disappears completely, it just changes form. Chapter 14. The Western Interior Seaway. An ocean. Through the heart of a continent. Let us travel now to a different ancient sea, not as old as the Tethys, not as vast, but in its own way, just as remarkable. We're going to North America, not the North America of today, with its mountains and plains and dry deserts, but a North America of about 80 to 100 million years ago in the late Cretaceous period, a continent that looked nothing like the one you might picture on a map. During the Cretaceous, sea levels were very high, much higher than today. The polar ice caps were gone, melted in the warmth of the Cretaceous climate. The deep ocean basins were slightly elevated compared to today. And because of all this, the shallow interior of North America was flooded. An enormous shallow sea stretched from what is now the Arctic Ocean in the north all the way to what is now the Gulf of Mexico in the south. It divided the North American continent roughly in half, separating the mountainous western portion from the flatter eastern portion. Scientists call this body of water the Western Interior Seaway. At its widest, the Western Interior Seaway was perhaps 1,000 kilometers across. Its depth varied from very shallow near the shores to perhaps several hundred meters in the deepest parts of the central channel. It was warm, tropical to subtropical in climate, with water temperatures much higher than the seas of today. Imagine you are standing on a beach, not a modern beach, an ancient shore 85 million years ago. The sand beneath your feet is the same sand in many ways, warm and pale and gently yielding. The waves coming in are familiar waves, but the world behind you is not familiar at all. There are no humans, no buildings, no boats, no distant city lights. The land behind you is covered in a dense, humid forest, lush with ferns and cycads and flowering plants, which were still relatively new to the world at this time. Strange birds, and some of them with teeth, call from the trees, and in the water before you, in the shallow, sun-warmed shallows of the Western Interior Seaway, there are things moving that are nothing like anything in any ocean alive today. A long, sinuous shape breaks the surface briefly, then disappears. Not far away, a creature drifts near the surface, its enormous eyes scanning the water around it. It is a mosasaur, one of the great marine lizards of the Cretaceous, distantly related to modern monitor lizards. It is perhaps 6 or 7 meters long, its body serpentine, its jaws lined with peg-like teeth designed for gripping slippery fish. The mosasaurs owned the Western Interior Seaway. They were its apex predators. They hunted fish, ammonites, turtles, and each other. Some species of mosasaur grew to enormous sizes, 12 or 15 meters long, and were among the largest marine predators that have ever existed. The Western Interior Seaway was also home to remarkable fish. Perhaps the most remarkable was a creature called Xiphactinus, a large predatory fish that could reach over 4 meters in length, with an upturned bulldog-like jaw full of large, sharp teeth. Fossils of Xiphactinus have been found with the remains of other large fish still intact inside their stomachs, prey that was swallowed whole so quickly that the predator itself died before it could digest its meal. There is something almost funny about that, in a quiet, dark way. Even at the top of your game, in one of the richest seas that ever existed, sometimes things do not go as planned. The Cretaceous Ocean was also home to enormous sea turtles. Archean, the largest sea turtle that ever lived, he swam in the Western Interior Seaway. It could reach nearly 4 meters in length, larger than a small car. Its shell was not the hard, solid shell of a modern turtle, but more like a leathery framework, lighter and more flexible, allowing it to dive and maneuver in the water. Imagine a turtle the size of a small car, drifting slowly through the warm, sunlit shallows of an ancient sea, its flippers moving in that slow, graceful arc that all sea turtles use, something between flying and swimming. It is a beautiful image, gentle and enormous and completely unhurried. Sleep reset. I want to pause here for a moment and invite you to check in with yourself. Where is your body right now? Are you lying flat? On your side? Are your muscles soft or still a little tense somewhere? Let your jaw loosen. Sometimes we hold tension there without noticing. Let it drop slightly. Let your teeth part just a little. Let your hands open, not reaching for anything, not holding on to anything. Just open and soft, resting wherever they are. Breathe in gently. Let the air fill you without effort, and then let it go. All the way out until you are empty for just a moment, and then breathe in again naturally, without trying. You are doing everything right. There is nothing to figure out tonight. There is only this soft darkness and this slow story and the quiet of the room around you. If you fell asleep somewhere back in the Tethys Sea and are just now drifting back into awareness, that is perfectly fine. You can pick up the thread anywhere. The ancient ocean is patient. It has been waiting for 252 million years. It can wait a little longer for you. Chapter 15. The beginning of the modern ocean. We are approaching the end of the Mesozoic era. We're standing in time on the edge of one of the most famous moments in the history of the Earth, 66 million years ago. The late Cretaceous. The world is warm and humid. Sea levels are still high, though they have been dropping slowly for millions of years. The Western Interior Seaway has been getting shallower and narrower, gradually draining as the land beneath it slowly rises. The Tethys is still present, though shrinking as the great continental movements continue. The ocean is still rich, mosasaurs still hunt, ammonites still fill the water column with their beautiful spiraling shells, giant sea turtles drift in warm currents, plesiosaurs, though less diverse than in the Jurassic, still swim in deep ocean waters, and then, 66 million years ago, an asteroid perhaps 10 to 15 kilometers in diameter, travelling at perhaps 20 kilometers per second, struck the Earth in what is now the Yucatan Peninsula of Mexico. The impact released energy equivalent to billions of nuclear weapons all at once. It vaporized rock. It sent enormous amounts of dust and debris into the atmosphere. It triggered wildfires across vast regions. It caused massive tsunamis in the surrounding ocean. And in the weeks and months that followed, the debris in the atmosphere blocked sunlight from reaching the surface, plunging the Earth into a period of cold and darkness that killed most of the plants that photosynthesis depended on. The food chains collapsed, on land and in the sea. The non-avian dinosaurs are the most famous victims of this extinction. But the ocean suffered enormously as well. The mosasaurs disappeared completely. The ammonites, which had survived multiple previous extinction events over hundreds of millions of years, vanished entirely. The large marine reptiles, the plesiosaurs and pliosaurs, were gone. The Cretaceous ocean, with all its richness and diversity, ended. But again, not everything died. The sharks survived, as they have survived every mass extinction. Some species of fish survived. The ancestors of modern whales, which at this point were still small land-dwelling mammals, survived on land. Sea turtles, in smaller numbers, survived. And in the deep, cold ocean, away from the worst of the effects, communities of simple organisms held on through the darkness, and slowly. In the Paleogene period that followed, the ocean began to recover and to change into something more familiar. The familiar, recognizable ocean of our own time was beginning to take shape. Marine mammals began to enter the sea. About 50 to 55 million years ago, a group of land-dwelling hoofed mammals began wading into shallow water, feeding on fish, gradually spending more and more time in the ocean. Over millions of years, their bodies changed. Their limbs became flippers. Their nostrils moved to the tops of their heads. Their bodies became streamlined. They became the ancestors of whales and dolphins. There is something extraordinarily moving about that. An animal standing on the shore, not thinking about anything beyond the fish in the shallow water, stepping in just a little, then a little more, then a little more, yet over millions of generations until its descendants are the blue whale, the largest animal that has ever existed on Earth. The blue whale, which can be 30 meters long and weigh as much as 200 tons, is the descendant of a small, furry, hoofed animal that once walked on land. Its evolutionary cousins, the hippopotamus, still live mostly on land today. The ocean shapes everything it touches. Everything that enters it is changed by it, slowly and completely. The ocean does not hurry this process. It does not need to. It has all the time in the world, and so do we, on this quiet night. There is no hurry. There is no destination. There is only the slow, soft drift of this ancient story carrying us forward. We've travelled so far tonight, from the Hadean rain to the first life in the Archean Sea to the Cambrian Explosion, to the age of fishes, to the great dying, to the rich Tethys Sea, to the Western Interior Seaway, to the end of the Cretaceous and the beginning of the modern ocean. Each chapter has been its own world. Each ocean has been its own universe of living things, most of them now gone, most of them known to us only through fragments of stone and the patient work of scientists who spend their lives asking what life was like in seas we will never see. But those oceans were real. They existed. They were full of sound and movement and the quiet business of living and dying and becoming something new. And we are the inheritors of all of it. Every ocean that ever existed on this earth contributed in some way to the world we are born into. The oxygen in the air we breathe was made by ancient cyanobacteria in the Archean Ocean. The chemistry of our blood is eerily similar to the chemistry of ancient seawater. The calcium in our bones was once dissolved in a Cretaceous sea. We are made of all of it, of every forgotten ocean, of every ancient wave. Let that thought settle in you gently, like sediment settling through still water. You're ancient, not in the sense of being old or worn out, but in the sense of being connected to something that goes all the way back to the beginning of this world. You carry within you the chemistry of the first ocean, the evolutionary legacy of creatures that lived in seas that have been gone for hundreds of millions of years. You're not separate from the deep past. You're its continuation. And on a quiet night like this one, when the room is dark and still and the world outside is asleep, it is possible to feel that connection, if only very softly, if only at the very edge of awareness. Just for a moment, feel it. The long, unbroken thread that connects you to the first warm rain that fell on a cooling earth and gathered in the low places of the rock and became the first ocean. You're part of that story. You've always been part of that story. Let your breathing slow a little more. Let the space between each breath lengthen gently. Let the words become softer in your mind, more like music than like language. The story has more to give. Part 4 is waiting, with its gentle reflection and its quiet deepening, as we move toward the end of this long ancient journey. But for now, just rest here. In the Paleogene Ocean, 50 million years ago, warm surface water, a distant whale song just beginning, not yet the complex, haunting music of modern whales, but something simpler, softer, the first tentative sound of a new kind of voice in the sea. Listen for it. You might just hear it, very faint, at the very edge of your hearing. The ancient ocean is still singing, it has never stopped. The world turns slowly, and so do we. We left the Paleogene Ocean behind us, that warming, recovering sea with its first whale song just beginning, soft and tentative, rising through water that was still learning how to be the ocean we know today. Now we drift forward, more slowly than before. We are not rushing toward new facts or new chapters of deep history. We're beginning to turn, gently, like a tide that has gone out as far as it will go and is now easing back toward the shore. This part of our journey is a quieter thing, a little less discovery, a little more reflection. We will still visit new places and new times, but the pace will be softer. The spaces between ideas will be a little wider, a little more open, like the long pause between one wave arriving and the next one forming somewhere far out at sea. If your eyes have been closed for a while now, good, let them stay closed. If your body has grown heavy and warm, let it be heavy and warm. If your thoughts have become loose and shapeless, drifting without direction, that is exactly right. We are in the home stretch of this long ancient journey, and the way home is always the gentlest part. Take one slow breath, in, soft and full, and then out, easy and complete. Let us begin. Chapter 16. The Cooling World, the Eocene and Oligocene Oceans. About 50 million years ago, the Earth was a very warm place. Scientists call this warm period the Eocene, and during its peak, sometimes called the early Eocene climatic optimum, the world was perhaps 10 to 14 degrees Celsius warmer than it is today. There were forests growing in Antarctica. Crocodiles lived near the Arctic Circle. The poles were ice-free and green, and the ocean was warm too. Warm and clear and rich with life. This was the world in which the early whales were learning to swim. The world in which the ancestors of modern dolphins and porpoises were still small, dog-sized creatures wading in shallow coastal waters. The world in which enormous seabirds with wingspans of 6 or 7 meters, called pelagornis, were beginning to soar over the open ocean, skimming the surface for fish. The Eocene ocean was not so different from the ocean we know today, in terms of its basic structure and inhabitants. The Great Extinction at the end of the Cretaceous had cleared away the mosasaurs and ammonites and giant marine reptiles. In their place, mammals were filling the sea. Fish continued to diversify. Sharks remained, as they always have, patient and perfectly shaped for their world. But slowly, beginning around 34 million years ago, something began to change in the Earth's climate. The world began to cool. The transition from the warm Eocene to the cooler Oligocene epoch, about 34 million years ago, was one of the most significant climate shifts in the last 100 million years. Antarctica, which had been drifting southward for millions of years, finally separated completely from South America, opening a deep ocean passage called the Drake Passage between the two continents. This sounds like a small geographic detail, but it had enormous consequences. Before the Drake Passage opened, ocean currents around Antarctica were partly blocked by the connection to South America. When the passage opened, a powerful circular current called the Antarctic Circumpolar Current was established, flowing endlessly around Antarctica with nothing to stop it. This current isolated Antarctica thermally. It prevented warm tropical water from reaching the southern continent. Antarctica began to cool. Ice began to form. And as Antarctica froze, sea levels around the world dropped, and the global climate shifted toward cooler conditions. The ice sheets that began forming on Antarctica 34 million years ago are still there today. We are living in the long tail of that cooling, in a world that has been slowly getting colder. With periodic ice ages, for the last 34 million years, it is a strange thing to realize that the formation of a single ocean passage, the opening of a gap between two continents, could change the entire climate of the Earth. That one geographic event could set in motion a chain of consequences that led, eventually, to the ice ages that shaped the landscape of the Northern Hemisphere, that carved the Great Lakes, that pushed human populations around the globe, that influenced the development of agriculture and civilization. The ocean connects everything. The ocean has always connected everything. A current in the deep south flowing around a frozen continent shapes the weather of London and the rainfall of the Sahara and the growing seasons of the American Midwest. The ocean is not separate from our lives. It is woven through them, and invisibly in every breath of air we take and every meal we eat. For a moment, just breathe. Let the thought of that vast, invisible connection rest gently in your mind. You do not need to understand all of its workings. You do not need to trace every thread. Just feel the quiet sense of it. The world as one connected, breathing system. The ocean as its slow, patient heart. Your own heart is beating right now, slowly, if you are relaxed, steadily, without effort. You do not need to think about it. It just keeps going, beat by beat, while you rest. The ocean is like that. It keeps going, current by current, tide by tide, wave by wave, while the world rests and changes and carries on. Let your body be heavy. Let your mind be quiet. The room is dark and safe and still. Chapter 17. The Ice Age Oceans. We are approaching something close to our own time now. Not our time exactly, but close enough that the world begins to look more familiar. The the coastlines beginning to take shapes we might recognise, the creatures in the ocean beginning to resemble the ones we know today. We are entering the Pleistocene epoch, which began about 2.6 million years ago and ended about 11,700 years ago. This is the period most people think of when they say Ice Age, though in truth, the Earth has had many ice ages throughout its long history. The Pleistocene was characterised by a rhythm of glaciations and warm interglacial periods, cycles driven primarily by small regular changes in the Earth's orbit around the Sun. Over periods of roughly 100,000 years, the climate would shift, or the ice sheets covering the poles would advance, spreading down over much of the northern hemisphere. Then they would retreat, then advance again, then retreat. Each advance and retreat changed the ocean in significant ways. When the ice sheets were at their maximum extent, enormous volumes of water were locked up in ice on land. Sea levels dropped dramatically. During the last glacial maximum, about 20,000 years ago, sea levels were roughly 120 metres lower than they are today. 120 metres. The coastlines of every continent were in completely different places. There were land bridges where there is now open water. Much of the shallow continental shelf, the gently sloping platform that extends from every coastline before dropping into the deep ocean, was exposed as dry land. The shallow seas that now lie over the continental shelves were once, during the Ice Ages, landscapes. Rivers ran across them, animals walked on them. In some places, early humans lived and hunted on what is now the seafloor. There is a quiet strangeness to that. The seafloor of the North Sea between Britain and Scandinavia was once a vast cold plain, roamed by woolly mammoths and woolly rhinoceroses and the early human ancestors who hunted them. Fishermen today sometimes dredge up the bones of these animals from the seafloor, along with, occasionally, ancient stone tools. The remnants of a world that was drowned when the ice melted and the sea returned. Scientists have given this lost landscape a name, Doggerland, a world that existed and was inhabited and was swallowed by the rising sea. Gone so completely that it exists now only in fragments on the seafloor and in the patient research of marine archaeologists. This is what the ocean does. It advances and retreats. It gives and takes. It covers and uncovers. The coastline is never fixed. The boundary between sea and land has always been a negotiation, an ongoing conversation between the weight of water and the height of the land. The coastline you were born near, if you were born near a coast, is not permanent. It was different 10,000 years ago. It will be different 10,000 years from now. The ocean is always moving, always adjusting, always patient in its negotiations with the land. There is something quietly liberating about that. Nothing is fixed. Nothing is truly permanent, not on the time scale of the ocean. Even the most solid-seeming things are in the process of changing, just so slowly that we cannot see it in a single human lifetime. We live quickly, the ocean lives slowly, and in between, we do our best to understand each other. Chapter 18, The Deep Ocean, a world we have barely seen. We have travelled across billions of years of ocean history tonight. We have visited shallow tropical seas and cold polar waters, ancient reefs and open ocean depths. But there is one part of the ocean we have not yet visited, a part that in many ways is the most mysterious of all, the deep ocean. Below about 200 meters, sunlight no longer reaches. The ocean becomes dark. Not the soft, comfortable darkness of a room at night, with its familiar shapes and sounds. A complete, total, absolute darkness. A darkness that has never been interrupted by any light, natural or artificial, for most of the ocean's history. The deep ocean covers more of the Earth's surface than all of the land combined. It is, in many ways, the least explored environment on Earth. We have mapped the surface of the moon with more detail than we have mapped the floor of the deep ocean. We know more about some distant planets than we know about the deep trenches of our own seas. And yet, the deep ocean is not empty. It is full of life. In the 1970s, scientists discovered the hydrothermal vent ecosystems we mentioned at the very beginning of our journey. Those hot, mineral-rich chimneys on the ocean floor, surrounded by communities of creatures that live without sunlight, powered entirely by the chemicals rising from the Earth's interior. Tube worms as long as your arm, blind shrimp, pale crabs, creatures that have never seen light and have no need for it. These ecosystems are found along the mid-ocean ridges, the great underwater mountain chains that run through the centres of the world's ocean basins, where tectonic plates are slowly spreading apart and new ocean floor is constantly being created. Imagine sinking down very slowly through the deep ocean, the light fading above you as you descend. First the bright blues and greens of the surface, then darker blues, then a dim grey-blue twilight, then, below 200 meters, darkness. You keep sinking. The pressure around you is enormous, many times the pressure at the surface, but you feel it as a kind of weight, a heaviness, a compression that is almost peaceful in its thoroughness. At around 1,000 meters, you begin to notice something. Points of light, not from above, from all around you. Creatures in the dark water making their own light. Bioluminescence, the cold, blue-green glow of living things signalling to each other in the absolute darkness of the deep ocean. A fish with a luminous lure dangling from its forehead drifts past. A squid pulses with light along its body. Tiny crustaceans trail glowing threads behind them. In the deep ocean, light is not something that comes from outside. It is something that life makes for itself. It is one of the most beautiful things that exist in the natural world, and almost no human has ever seen it directly. Most of what we know about bioluminescence in the deep ocean comes from remote cameras on underwater vehicles. Tiny windows into a world that has been dark and alive for hundreds of millions of years. Life has been in the deep ocean for an extraordinarily long time. Long before complex creatures evolved in the shallow seas of the Cambrian, microbial life already occupied the deepest parts of the ocean floor, living in the sediment, surviving on the barest traces of organic matter drifting down from above. Scientists call this slow rain of organic material marine snow. It is one of the most poetic names in all of oceanography. From the productive surface layers of the ocean, tiny particles of dead organisms, fecal pellets, discarded shells, fragments of algae, drift slowly downward, taking days or weeks to reach the deep sea floor, where they provide the only source of nutrition for many deep sea creatures. Marine snow, drifting down through the dark water, slowly, gently, endlessly, feeding the dark world below. There is something about the deep ocean that feels, to me, like the perfect image for sleep. That absolute darkness, that heaviness, that slow, quiet descent, the pressure that holds everything still, the faint, cold light of living things signalling to each other in the deep. If you're drifting towards sleep right now, imagine yourself sinking slowly, not falling, just sinking, soft and weightless, down through warm water, the light above you fading gently as you go deeper, the sounds of the surface world growing quieter and more distant, the darkness closing around you, not frightening, but soft, familiar, like a blanket, down and down, slowly through the dark and quiet deep. You're safe here. Nothing can disturb you. The deep ocean has been keeping its quiet for millions of years, and it can keep yours too for just one night. Chapter 19. What the Ocean Remembers. We are nearing the end of our journey now, not the very end. There is still one more part after this one, and it will be the softest and quietest of all. But we're close enough to the end that it is time to begin gathering the threads together. Not tying them into a tight knot, just letting them rest alongside each other, gently, the way different currents in the ocean eventually slow and merge and become one movement. We have visited so many oceans tonight. The Ediacaran Ocean, born from 1 billion years of rain. The Archean Ocean, warm and iron-rich, cradling the first life. The Cambrian Ocean, suddenly full of eyes and shells and motion. The Ordovician reefs and the Great Dying at the end of that period. The Age of Fishes, the Devonian and its own catastrophe. The Great Dying at the end of the Permian, the worst extinction this planet has ever known. The recovery, slow and patient through the Triassic. The warm, magnificent Tethys Sea and its mosasaurs and ammonites. The Western Interior Seaway dividing a continent. The asteroid and the world after it. The early whales learning to swim. The cooling of the Eocene. The Ice Ages. The deep, dark, bioluminescent world of the ocean's depths. Each of these is a chapter in a story that is still being written. The ocean we have today, the one that covers 71% of the Earth's surface, the one whose tides are pulled by the moon, the one whose currents carry warm water from the tropics to the poles, the one whose surface is alive with phytoplankton producing half the oxygen we breathe. This ocean is just the latest chapter. It is easy, living in the present, to think of the world as it is as the way it has always been. The continents in their current positions, the ocean in its current shape, the animals and plants that we know today as the natural permanent inhabitants of the Earth. But tonight, I hope you have felt something of the deep strangeness of time, the way the world has never stopped changing, the way the ocean has worn so many different shapes, held so many different creatures, touched so many different shores. The Atlantic Ocean, which separates Europe and Africa from the Americas, did not exist 200 million years ago. It was not a narrow sea. It was not there at all. The Americas were joined to Europe and Africa in the supercontinent of Pangaea. The Atlantic opened slowly as the plates drifted apart, growing wider by a few centimeters every year. It is still growing wider today. In another 100 million years, if the Earth continues as it has been, the Atlantic will be significantly larger than it is now. And somewhere else, another ocean may be closing. The Pacific Ocean, the largest ocean on Earth, is actually shrinking, very slowly. As the plates around it subduct, as the ocean floor is pulled down into the mantle at the edges of the basin, the Pacific grows smaller year by year. In the very deep future, it may close entirely, and the continents surrounding it will collide to form a new supercontinent. The ocean is never finished. It is always in the process of becoming something else. For a moment, just breathe. Let that sense of slow, patient change settle into you. Not as a frightening thought, not as a thought that needs to go anywhere or do anything, just as a quiet awareness. Everything changes. Everything has always been changing. The ground beneath your feet has been ocean floor. The mountains on the horizon were once sediment on a seafloor. The air you breathe was made by organisms in an ancient sea. Change is not the enemy of comfort. Change is just the way things are, and knowing that can be, in a strange and quiet way, deeply restful. Because if everything changes, then nothing is stuck. No difficulty is permanent, no darkness lasts forever, not on the time scale of the ocean. The ice ages came and the ice ages melted. The extinctions happened and life recovered. The oceans closed. And new oceans opened. The world is always finding its way forward, and so are you. Chapter 20. The Ocean and the Human Heart. We are 4.5 billion years into the story of this planet. We are arriving very close to the end of that story at us, Human beings have been on Earth for an extraordinarily short time by geological standards. Our species, Homo sapiens, appeared roughly 300,000 years ago. Modern human civilization, with its cities and writing and complex societies, is only about 10,000 years old. In the timeline of the Earth, we are the last few seconds of a very long film, and yet we have always felt the ocean. We have always been drawn to it. The earliest human fossils found near coastlines show evidence of shellfish eating, of gathering food from tidal pools, of living in close relationship with the sea. Long before we built boats or sailed across open water, we walked along the edge of the ocean and looked out at it and wondered. That wondering never went away. If anything, it deepened as we learned more about what the ocean holds, about how deep it goes, about how old it is, about the creatures living in the perpetual darkness of the deep trenches, about the history written in the layers of sediment on the seafloor. The ocean fills us with awe, not the loud, startling kind of awe, the quiet kind, the kind that makes you feel very small and very still, and somehow very calm. Scientists who study the psychological effects of being near the ocean have found something fascinating. Being close to the sea, hearing its sounds, watching its movement, has measurable calming effects on the human nervous system. Heart rate slows. Breathing deepens. The activity in the parts of the brain associated with stress and worry decreases. Some researchers call this the blue mind, the state of calm, gentle awareness that water seems to induce in human beings. Not sleep exactly, not sharp wakefulness either. Something in between, something like the state you might be in right now. There is probably a very old reason for this. We evolved near water. Our ancestors lived near rivers and coasts and lakes for hundreds of thousands of years. The sound of water, the sight of water, the smell of water, these are not new things to our nervous systems. They are ancient and familiar, woven deep into our biology as signals of safety, of resources, of home. When you feel calm near the ocean, or when you feel calm listening to the sound of rain, you're responding to signals that your ancestors responded to, stretching back not just through human history, but through all of mammalian history, through all of vertebrate history, all the way back to those first creatures crawling out of the Devonian Sea onto the shore. The ocean calms you because, in a sense, you remember it. Not consciously, not in any memory you could describe, but in the oldest, quietest part of your biology. The ocean is home. It has always been home. It is where everything began. Let your body sink a little deeper into wherever you're resting. Let the weight of all those billions of years settle gently around you, like warm water, like the first ocean before anything, just the soft, dark, warm embrace of ancient water. You are heavy and still, your breathing is slow, the room is quiet. You have travelled so far tonight, and you're nearly home now. One more part of this journey waits for you, the softest and the quietest, like the last few minutes before sleep takes you completely. But before we get there, let us rest here for just a moment, in this chapter, in this quiet space between the deep past and the deep future, in this present moment, which is the only moment any of us ever truly inhabit. You are here, you are alive, you are breathing, and the ocean, patient as it has always been, is still turning, still moving, still making waves on shores all over the world. In the dark of this same night, under the same stars, the world turns slowly, and so do we. If you are asleep now, that is the most natural and beautiful thing. You have let the ancient ocean carry you all the way to sleep, and that is exactly what this journey was for. Rest there, in the deep, warm, quiet dark, and if you're still with me, still floating in that soft, half-lit space between waking and dreaming, then just close your eyes a little more. Let the next breath be slower. Let the one after that be slower still. We are almost there. The world turns slowly, and so do we. We are here now, the last part of our journey. There is no hurry in these final pages, no new discoveries waiting to surprise you, no sharp turns, no sudden depths, just the slow, gentle shore at the end of a very long voyage, just the soft sand beneath your feet, and the quiet sound of water arriving and leaving, as it always has. If you're still awake, I am glad you stayed with me this long. And if you have been drifting in and out of sleep through these last few hours, that is exactly right. That is what this journey was always for. Take one last slow breath with me now. In, soft and easy, and out all the way, gentle and complete. We are almost home. Chapter 21. The Ocean at the Edge of Now. We have travelled through 4.5 billion years of ocean history tonight, through rain and fire and the first quiet life, through extinctions and recoveries, through creatures we will never see with our own eyes, preserved only in stone and in the patient imagination of scientists who love the deep past. And now we arrive at the edge of the present. The ocean today covers about 361 million square kilometres of the Earth's surface. It holds about 1.335 billion cubic kilometres of water. It has an average depth of about 3,688 metres, and in its deepest place, the Mariana Trench in the Western Pacific, it reaches nearly 11,000 metres below the surface. It is home to an estimated 700,000 to 1 million species of living things, and scientists believe that perhaps 2/3 of all marine species have not yet been formally identified and described. There are creatures in the ocean today that no human has ever seen. Living things in the deep, cold dark that have no names in any human language yet. The ocean is still full of mystery, even now. Even after all our technology and all our exploration and all our centuries of seafaring and science, the ocean keeps its secrets quietly without effort, the way a deep, still lake keeps its depths hidden, even on a perfectly clear day. The modern ocean is, in many ways, the most complex version of itself that has ever existed. After 4.5 billion years of evolution and extinction and recovery and change, the web of life in today's ocean is extraordinarily intricate. Every creature is connected to dozens of others. A change in one population ripples outward through the whole system, like a stone dropped in still water, the rings spreading outward in every direction. The great whales, whose ancestors we watched learning to swim in the warm Eocene ocean, are now some of the most important animals in the entire marine ecosystem, not just because of their size, but because of what happens when they dive and surface and feed and defecate. They move nutrients from the deep ocean to the surface, fertilizing the phytoplankton that produces much of the world's oxygen. A single great whale, over its lifetime, cycles enormous amounts of nutrients through the ocean system. When the whales are well, the ocean is well, and when the ocean is well, the air is well, and when the air is well, everything on land is well too. Everything is connected. The ocean taught us that. The ocean has always known it. The phytoplankton, those microscopic single-celled plants drifting in the sunlit surface waters of the ocean, produce somewhere between 50 and 80% of the oxygen in Earth's atmosphere. Every other breath you take was made in the ocean, in the open sea, by creatures so small that millions of them fit in a single drop of water. You breathe the ocean with every breath, even here, in your room, in the dark, far from any shore. The air moving in and out of your lungs is partly ocean air. It was made by tiny living things in the surface waters of the sea, drifting on invisible currents, catching sunlight, releasing oxygen, doing what they have done since the Archean, quietly and continuously, for billions of years. The ocean breathes, and in breathing, it keeps us alive. For a moment, just breathe. Notice the air entering you. Notice how effortless it is. Your body knows how to do this. It has always known. It learned, over hundreds of millions of years of evolution, exactly how to take this gift from the air and use it to keep you alive. You do not need to try. You do not need to think about it. Your body simply breathes, and the ocean, far away, simply makes the air. And somehow, across all that distance and all that deep time, the two of you are in conversation. A very quiet conversation, but a real one. Chapter 22. What remains? The ancient oceans we have visited tonight are gone. Not entirely, in the way that a fire goes out or a sound fades into silence. More the way that water changes form. They evaporated into the sky and fell as rain, and became rivers and seeped into the ground and rose again as springs. They were incorporated into the bodies of ancient creatures who died and became sediment and were compressed into rock. They became part of the mantle when ocean plates were subducted, and they were released again as steam from volcanoes, rising into the atmosphere, becoming clouds, becoming rain again. The water in the modern ocean is, in a very literal sense, the same water that filled the Tethys Sea and the Cambrian Ocean and the Archean Sea and even the first, ancient Hadean Ocean. Not the same individual molecules in the same places, of course, but the same water. Recycled and re-recycled over billions of years through the sky and the sea and the rock and the living things that have inhabited this planet since its earliest days. The water in your body right now has been ocean water. Probably many times, it has been rain and river and glacier and seafloor. It has been inside other living things, perhaps many of them, over the billions of years of Earth's history. You are not separate from the ancient ocean. You never were. You are the ancient ocean, in one of its many, many forms. There's a kind of peace in that. A quiet, grounding, deeply restful kind of peace. We spend so much of our lives feeling separate. Separate from nature, from history, from the deep past. We live in rooms and cities and routines that can make the world feel very small and very recent. As if everything that matters began with us, or shortly before us. But tonight, I hope, you have felt something of the other truth. The truth that the world is unimaginably old. That life has been finding its way on this planet for nearly 4 billion years. That the ocean has been patient through every catastrophe and every recovery. That the water falling as rain outside your window tonight is the same water that once filled a Jurassic Sea. You are part of something so vast and so old that the mind cannot fully hold it, and that is okay. It does not need to be held, it just needs to be felt, gently, at the edge of sleep. Chapter 23. The Gifts of the Forgotten Sea. Each of the ancient oceans we visited tonight left something behind. Not just fossils in rock or chemical signatures in stone. Something more. The Hadean Ocean left us our water, the most essential substance for all life on Earth, gathered from that first ancient rain and never truly lost, only changed, only transformed. The Archean Ocean left us our oxygen, made by cyanobacteria over hundreds of millions of years, slowly, patiently, filling first the ocean and then the sky with the gas that makes complex life possible. The Cambrian Ocean left us our body plans, the basic blueprints of vertebrate anatomy, of jointed limbs and bilateral symmetry and eyes and mouths and guts, were laid down in that extraordinary explosion of life 500 million years ago. The shape of your body traces its origin to the Cambrian Sea. The Ordovician Ocean left us our reefs. The principle of the reef, of small creatures building vast structures that shelter enormous communities of life, was established in those ancient coral and stromatoporoid reefs over 450 million years ago. The the Devonian Ocean left as our lungs. The lobe-finned fish that dragged themselves across the Devonian mudflats, moving from one drying pool to another, became the ancestors of all land vertebrates. Their muscular fins became our legs. Their primitive lungs became our lungs. The air we breathe passed through shapes that began in a Devonian fish. The Permian Ocean left us its lesson. That even the worst catastrophe, even the near total destruction of life on Earth does not end the story. That life persists. That recovery is always possible. That after the darkest chapter, something new and unexpected and full of possibility will find its way into the empty spaces. The Mesozoic oceans left us our mountains, the Alps, the Himalayas, the limestone hills of southern Europe, all built from the compressed remains of Tethyan creatures. Every time you look at a mountain, you are looking at the remains of an ancient sea. The Eocene Ocean left us our whales, those magnificent, gentle giants that move through the modern ocean singing to each other across hundreds of miles of water. They came from the land, they went back to the sea, and in doing so, they remind us that nothing is fixed, that the boundary between what something is and what it might become is always more fluid than it appears. These are not small gifts. They are the foundations of the world you live in. The air, the water, the shape of your body, the mountains, the creatures in the sea, the forgotten oceans gave all of it, and they asked for nothing in return. They simply were. They simply changed. They simply passed what they had to the next thing, and the next and the next, all the way down the long river of time to this moment, this room, this breath. Chapter 24. The shore at the end of the journey. We are very close to the end now. The ideas are becoming softer, the chapters are becoming shorter. The words are slowing down, like waves becoming smaller and quieter as they approach a sheltered shore. If you're still awake, your eyes may feel very heavy. That is good. Let them be heavy. There is nothing left to see tonight. Everything important has already passed through you gently, like water through a net. What stays, stays. What drifts on, drifts on. Both are fine. If you're half asleep, let yourself go further. There is no edge to catch yourself on. Just soft, warm depth. Patient and still, waiting to receive you. The ancient ocean does not end. It just becomes something else. It becomes the next thing and the next, and somewhere far down the chain of transformation, it becomes this moment, this room, this breath, this quiet. I want to tell you something before we finish. You're living in a remarkable time, not a perfect time, not an easy time, but a time in which human beings know more about the deep history of this planet than any human beings have ever known before. A time in which we can look at a piece of rock and read billions of years of ocean history written in its layers. A time in which we can reconstruct the chemistry of a sea that existed before the first animal ever lived. We can know these things, we can hold them, we can pass them on. And there is something in that knowing that is deeply comforting. Because the more you know about the deep past, the more clearly you can see that the present is not the final word. The present is just a chapter. A beautiful, complicated, temporary chapter in a story that goes on and on and on, far beyond anything any of us will live to see. The Earth has survived worse than anything we know. It has been struck by asteroids, flooded by volcanic eruptions, covered in ice, nearly stripped of its ocean life. And every time, slowly, patiently, beautifully, it has recovered. Life recovers, the ocean recovers, the world recovers. It always has, and on the long, slow time scale of the Earth, it always will. Chapter 25. The Last Wave. We are at the very end now. I want you to imagine one last image. A simple one. Not dramatic, not grand, just a beach. Somewhere quiet. It does not matter where. It could be any shore on any sea. The light is low, the way it is in the late evening when the sun has gone but the sky is still softly bright. The air is warm and a little salty. The sand is pale, and the ocean is coming in, very gently. A wave arriving at the shore, moving slowly up the sand, white and soft at its edge, hissing very quietly as it spreads thin and exhausts itself, and then pulling back, slowly, back into the body of the sea, and another wave coming, very slowly, following the same path, the same gentle arc up the sand, the same quiet hissing, the same retreat. This has been happening on shores like this for over 4 billion years, for longer than complex life has existed on this planet, for longer than any creature that left a fossil was alive. Long before any eye existed to see it, waves were arriving at some ancient shore, spreading thin and pulling back. The rhythm of the ocean is older than us, older than animals, older than almost everything we know, and it will continue long after we're gone. There is something in that rhythm that the body understands even when the mind is too tired to think. That slow, arriving and retreating, that endless, patient pulse. It is like breathing. It is like a heartbeat. It is like falling asleep, in and out, arriving and leaving. Arriving and leaving. Let it carry you now. You've been so patient tonight. You've travelled so far, through billions of years and forgotten oceans and ancient creatures, and the long, slow story of a world becoming itself. You do not need to remember all of it. You do not need to hold on to any particular fact or image. The journey itself was the gift, the slow drift through deep time, the permission to let the story carry you without needing to do anything with it. The ancient ocean does not need your attention to exist. It existed for billions of years before anything on Earth could pay attention to anything. It will exist in some form long after attention itself has changed into something we cannot imagine. You are just a visitor tonight, a kind and quiet visitor, drifting through a vast and patient story. And now the story is gently setting you down, on the softest shore, in the warmest dark. Let your body be completely still now. Let your arms be heavy. Let your legs be heavy. Let your chest rise and fall without any effort at all, because it knows how. It has always known how. It learned how before you were born, and it will keep going all through the night without any help from you. Let your thoughts, if there are any left, become slow and loose. Let them drift apart from each other. Let them become shapes without meaning. Let them become colours without names. Let them become nothing at all. The room is dark. The world outside is sleeping. The ancient ocean, far away on every shore of every continent, is still breathing, still sending its waves up the sand and pulling them back. He's still turning its deep currents through the cold, dark water, still holding its creatures, its mysteries, its billions of years of patient memory. And you are safe in this room, in this darkness, in this night. You do not need to go anywhere. You do not need to be anything. You do not need to remember the Tethys or the Cambrian or the Great Dying or the first rain that filled the first ocean. All you need to do is breathe. In, soft and slow. Out, easy and complete. In, out. The world turns slowly, and so do we. Thank you for travelling with me tonight through the forgotten oceans of prehistoric Earth. Thank you for your patience and your quiet and your willingness to drift. You are safe. You are warm. You are home. Rest now. The ancient ocean will be here in the morning, and so will you. Sleep well.